So again, I'm just going to remind everyone that this meeting will be recorded and it will be posted on the Substation Design Suite website or on the SBS YouTube website. The SBS YouTube website is in the chats. If you look on your webinar chats, you will see the location of that website that we'll post it on. There is also a handout available. It just summarizes the toolbars that we will be going over in this short webinar. I want to stress with the Substation Design Suite web page that once you purchase the software, you're able to log in to the Substation Design Suite website, and you're able to download and look at different items we have here. The main thing here is we got the course. We have a Substation Design Suite course that you can go through on your own or with one of our trainers. And in this course, we talk about, even the first day, we talk about the best practices for creating your substation with Inventor. And we also talk about, of course, the software itself and best methods to use it. If you take this course, there's a download of course materials, and it's actually a hands-on course that you will be doing some modeling and some practice efforts. What's also in the Substation Design Suite website is a tremendous amount of help items. So if we get into the help items, you can come in here and you look at some installation ideas, the how to work with the database, but it also gets into the tools themselves, and there are videos of the tools and how to use them. So if you follow the videos, you can follow that as well. Most of these are downloadable. You can save the video off the website for later reference. There is also a fair amount of content for working with the software, and you're able to download that as well. So those are the key things with the website that you can download. Also, once you sign into the website, you're able to download the software, whichever version you wish to, whichever version you need for whatever Inventor version you have, you're able to download the software. New on here is some templates that you can use with SDS for Inventor. These are Inventor templates, part and assembly templates that are set up to work nicely with SDS. So that is also available. So let's get into the software itself. In here, I have opened up a small assembly. You can see the assembly. It has a transformer, has a high side and a low side, has a little bit of lightning and some shelter in here. And what we're going to do, we're going to run some of the components in here. But just quickly first, I'll show you what Substation Design Suite is doing here. I have Inventor Professional 2017 open. And in here I have add-ins. So just to show you where this is the Substation Design Suite is an add-in to Inventor. And here we can see it here. So it lays on top of Inventor. You must have Inventor available. And of course we work with 2015 Inventor all the way through to 2018 Inventor. So once you have it laid in the add-in active in Inventor, you can look at the menus that are available. There are 3 menus available. There's Substation Design Suite. This is the design section. We have design checks, bill of material, design of bus design, drawings, several tools in here, import a surface, a Civil 3D XML. So that's one page you get. The other menu is above grade tools, and this is where we can place fittings. We can place various fittings in here. And we can place these fittings. All the menus can be customized and configured to what your needs are. We can also place rigid bus routing, cable routing, and that's some of the stuff we're going to do today in a couple of minutes. You also get the below grade tools. The below grade tools are the trench, conduit, and grounding, and we can lay all of that in. We'll touch on that today as well. But also in Substation Design Suite, we have the configurable database. This database here is reading a database, of course, and we can customize that or configure it to what your needs are and get in the information what you need for a bill of material. So to get them your part number, your stock number, your descriptions as per what you require for your bill of material can be placed in here. So first of all, let's just about to show a little bit about the substation modeling strategy. In the help files, I quickly showed that in the help files that there is a documents in here to help you get through. There are some help files here to help you get through on the Substation Design Suite. And then here we talk about a substation modeling strategy. It's one thing to just start to model in Inventor, but you must have a good strategy to have a robust model in a successful substation. And this is what we're trying to do here. So we are giving you some information, even training on how to get that model together to work best with not only with SDS, but also to have a good model that your team can work with. And in this strategy, which you can download as well, once you sign into the website, you're able to do that. So that's what this model is based on, is that substation modeling strategy. If you look at it, we have it in sections. We have a lightning section. We have our bay. If we had multiple bays, we'd have multiple bays here. We have the underground, and even the underground is separated into the conduit, into the ground grid, and into the trench. And that's what we're going to look at as well today, is all of this. And that's what this model is based on. So the first thing I want to do is come in here and lay some cabling. Now this webinar is meant for beginners, and I'm going to show right from the beginning on how to place some cabling and bus, trench, and so forth. So of course I opened up the bay assembly. In the bay assembly, I'm going to place a couple fittings, and then I'm going to place some cable. So right in here I have my transformer, and I have my low side here, and what I need is a fitting on here and a fitting on here. So let's place some fittings first of all. So let's get into our above grade tools. We're going to come up here and we're going to browse and place a fitting. When you look in here, there's several items that we can choose. We can browse to a fitting, we can place a tap style fitting, or we can come into the cloud. We have a number of cloud fittings that you can bring into your models. Once you bring them in, you can add the metadata you need for the description of those items to fit your bill of material look and feel. But in this case, we're going to browse to a fitting, and I have my fittings located, and I'm going to bring in a fitting. I'm going to bring in this guy here, open, and I'm going to place it on this NEMA pad. So what we're looking at is a NEMA pad into NEMA pad arrangement, and that's what places that in. What I also need is a fitting on this other stud location, so let's place that fitting as well. Again, this is a beginner's thing, and I think it's really worthwhile to see. So now I've placed this fitting here, but I don't like that rotation. I don't like that item, how it's placed there. So I'm going to rotate that item, and I'm going to say, just to show the rotation tool, I can rotate right around and bring it back. So let's rotate that item again. I just wanted to show it going around in a 360. So here I have is my fittings all placed to place my cable. And I'm going to place a cable similar to that. I'm going to check my settings for the cable. Each toolbar has its own settings. And once we look at that, we got a 500 MCM copper cable. So that's what I'm going to place in there. 500 MCM. This again can be all customized to whatever you need in the descriptions you need or configured for that. I'm going to add a sag to my cable to make it look realistic in this case. If you're running long cables and you know your sag from your calculations, this is where you would put it in. And I'm going to save that. Again, there will be questions and answers at the end of this. I'm going fairly fast and I'll take your questions at that time. So we're going to run a cable, and I got several choices here. I can pick 2 fittings to add cable, pick points, pick fittings. So there's several types of things we can pick here, but I'm going to pick fittings because I'm going to pick multiple fittings. So let's pick fittings. I'm going to pick the first fitting, the second fitting, and the third fitting. Enter, and with that we have our cable placed. And you can see the cable is placed here. It ran a little bit slow there because it's the first cable we've laid. Now that it's identified everything, it will place it in. You're responsible for putting in the right fitting for that cable size. The software does not identify the fitting to the cable size. A lot of fittings fit multiple cables, and it's difficult to identify what size you would need. But that could be a future tool to add on. What we also want to do is place a dual cable here. So let's place a dual cable. And I'm looking in here and I'm looking at what I need. And you can see I need a fitting up here. So let's place that fitting. I'm going to come into my configured fittings. And I'm going to grab my configured fitting. Let's grab that guy here. And we'll place them on there. So there I've added my fitting. And I want my cables to come from this fitting down to this fitting, and I want dual cables. I'm going to leave my settings as the copper cable that I placed earlier so that we can easily visibly see it being placed, but also in the settings I can place in a cable spacer. So what we're going to do, we are going to pick 2 fittings to add cable. I'm going to pick this fitting, we're going to pick this fitting, and with that our cable will be added. You can see that operated a little bit faster because we've run it once already. If we look at the cables, a lot of people ask, well, we have the cables, and then what? Let's open up a cable. And I just want to show that in the bill of materials, when this comes into the bills of material, it will sum up the number of feet added. So this cable length is 4.8. And a lot of digits. It's 4.8 feet. So when you place all the cable in, it will totalize your cable length used in your model. And we can have that in there. Now often when we're in the bus area, we want to look at placing, in the Bay Area, we want to place some bus. So let's look at placing some bus. First off is this flat bus here. You can see my flat bus bent and arranged like that. The default arrangement for the bus is to bend it in an efficient manner. So let's look at placing a piece of flat bus. This is just flat bar. Again, I have my settings. I can look at my bus and I can see that I have a 4-inch round bus. I got 4-inch flat bar and a 4-inch angle iron preset. So I'm going to place these guys in. So let's place some flat bar. We're going to come into our tool and place 2 surfaces to add flat bar bus. We're going to add this surface and we're going to add this surface. So here you can see the flat bar bus is added. What we also want to do is add maybe some angled bus, and you can see where we want to add some angled bus along this area. And we wanted to come across here. So let's add some angled bus. Let's pick 2 surfaces to add angled bus. And there's my 2 surfaces picked, and you can see the direction of my angle as well. If I want to add another angle, I can add my 2 angle surfaces, pick my 2 surfaces again, and it adds it in the opposite direction. So we got our 2 pieces of angle bus located. Round bus is another location. We want to add maybe some round bus to this area here. So we'll come up to settings, we'll look at our round bus options, And we'll see that, well, we want to overhang, let's say 12 inches on the positive. We always need the inch item in there in case we want centimeters or millimeters for others. And let's place this guy in here. So we're going to pick 2 fittings to add our bus. And that will be a 12-inch overhang from the center of the bus. So if I were to measure from the center of the bus to the center of the end, I would get 12 inches. You can see the 12 inches in the Y direction here. So you can see that's being done there. Again, I'm going a little fast for this just to get through it. It is being recorded, and I'll take questions at the end. So now that we have this added, we may want to do other bus work as well. So let's go over to the high side voltage, and we're going to look at the high side here, and we're going to open that up. Again, this is part of the substation modeling strategy that we are going to, that we have this all worked out on the substation modeling strategy, that we have their sections based, and it makes it a little bit smaller and lighter areas to work on rather than an enormous model that you can get lost on. So what we want to do, we want to place a piece of bus in here in the B phase. So we can go to our above grade tools, and we're going to place a fitting, and we'll place a bus fitting here. And then we can place a bus fitting over here as well. And again, I'm going a little fast, but this will be recorded, and we can go over it at a future date. So I got my 2 fittings in here, and now I want to place a piece of bus in that. And with that, I will come to my bus. I'll check out that I want round bus 4-inch. I'll go with that. I don't want a 12-inch overhang. I want a negative 0.5-inch overhang in this case. So I'm going to place my bus. Let's pick 2 fittings to add bus. This guy to this guy. And there's my bus. Like the cable, what we looked at earlier, the cable was identified in the lengths and totalized. This is doing the same thing. If we look at the length of this piece of bus, it's 29 feet long. This gets totalized as well in the bill of material, so you know exactly how much bus you're using for this size of bus. The part numbers and stock numbers and descriptions can all be edited, and that can be done in the database setup. So here I have my piece of bus. If I want to add fittings to the bus, we can add different types of fittings. I'll show you a simple one here. Is maybe a vibration dampening fitting I can place right here. And there's my vibration dampening piece added to the bus. So there's different ways to do that. If we wanted to run a cable inside that, we'd use our cable tools, and we could run a cable inside there for vibration dampening. So you might be curious on how some of these fittings are being added. If you look at the fittings, there is information added to those fittings. So part of the help files to download that you can read is work geometry for automation. And in those downloads, you can download this file, and you can read and understand not only where we're placing it and a little bit on how to configure your menus, but it gets into the parts and what work geometry that needs to be added to the part so it can be used in the automated tool of SDS. Now what we are doing is creating cloud content, and the cloud content is continually growing, and it's going to be awesome in the fall when we have a new update, and we have it available here too still. So if you wish to come into the cloud fittings, you'll be able to browse the cloud and bring in a cloud fitting as well. But if you're making your custom fittings, you would need to follow the requirements of the work geometry for automation. So that's just a simple little thing that we ran. We've placed some bus, we've placed some cables. I'm going to look at some underground stuff. We'll look at some trenching and conduit. And again, I'll take questions at the end, and this is being recorded, and we can refer to that recording at a future date. Maybe about a day it'll be posted on the SDS YouTube site. You'll find that location in the chats of the webinar tool. All right, so let's look at the underground. Again, this is substation modeling strategy that we're following here. Now I'm going to open up the trench. This is its own assembly, and I got a trench sketch running here. And a lot of Inventor stuff runs on creating a model from a sketch, and SDS does that as well. It's a proven way of doing things, and it works quite well. So we can go into our below-grade tools. Now in the below-grade tools, we have settings again, but we also have grounding, below-grade cable, trench, and conduit. So it's the trench stuff we're going to look at here. We can come into our settings, and we're going to look at what our trench settings are. We can configure our trench components as whatever you need to place them in, and we can add them to the toolbar as well. So right now I'm going to put a piece of trench in. I'm going to have prefab T's and L's. I'm going to add my trench covers, and I'm going to go with that. I'll save that. I want my trench along this sketch. And now it's going to place the trench on that sketch. These trench components are configurable and placed into the database for whatever you need. With that, I've placed my trench according to my sketch. If I had different sizes of trench, I would need different sketches, and then I would link them together. If you follow the substation modeling strategy, it does talk about what's good for that on the methods of doing that. And you can see the trench is placed in there. And that trench can be placed in. It can be configured as a length and total number of feet of trench or individual pieces. It all depends on how you've set things up. So I'm going to save that. Let's take a overall view of it, save it, and we'll look at it in the larger model. So you can see my trench has now been added. Let's look at the trench. And you can see that that trench is based on that sketch. Now we know where that sketch is because we followed the substation modeling strategy that I've showed the pages that are available for download earlier. If we wanted to place some conduit, let's open up the conduit. And again, I'm going fast. This is being recorded, and we'll take questions at the end here. So here's my conduit is open here, and I have conduit sketches, much like the trench sketches. In typical Inventor method is run items on a sketch. So I'm going to place a piece of conduit on here. Low grade tools, I'm going to look at my settings. I always got to look at your settings to make sure you have what you want so it to happen the way you want it to happen. So let's take a look at this. I'm going to say I want my conduit 42 inches below my reference plane. The reference plane is the XY plane typically, and typically if you follow the substation modeling strategy, the XY plane is the top of concrete plane. So let's get this just in the right orientation where we can see it place our conduit nicely. The conduit tools, there's several tools here. They're all available. And I'm going to go drop with path. So I'm going to come down here. I want my conduit to run from this location and follow this path. And with that, you can see the conduit is added. It follows a sketch, and whatever the sketch is going to be, it will follow. Now, of course, we would turn these sketches off when we're not using them, and we would save it. So let's turn the sketches off. I don't need to see them anymore. And I've got my pieces in here. It can get quite busy with conduit, and if you follow a substation modeling strategy, it gives you some ideas on how to get all that busy conduit into a station. So again, here's the little piece I've added is this one right here. Oh, let's change it's this piece right here I've added, and I ran from the box here where our man's standing, and we've come down to the pull box over there. So that's simply just placing a piece of conduit. If we look at the ground grid, I'll just open the ground grid real quickly. Again, don't have a lot of time, but the ground grid is using the same idea. If I come in here and edit the sketch, it is using a sketch to follow for creating the ground grid. Once it has that sketch, we can create the ground grid on top of it. The sketches can be imported from AutoCAD, so if you have a third-party vendor laying out your ground grid, which is often the case, you can import it directly into Inventor. That's just normal Inventor methods of doing things. And with that, once you run the ground grid tool, you can place your ground grids pieces. Now the idea here is the shot in a mold, the round shot and round mold. I know a lot of people are changing the way they want that to look. And of course, that's configurable in the database. We can also place our grounds to drop a ground. If I want to come in here, add a ground rod, I can just pick a point and add a ground rod. In this case, it's a 3-section, 20-foot length ground rod, total 20 feet length. And that can be customized again as well. So with that, we're going to close that. So with these items, we've added cable, we've added bus, we've added trench, different types of bus as well. We added trench, we can configure our trench types. We've added some conduit. What I'm going to show is the Substation Design toolbar now. So again, it's the 3 toolbars. They're add-ins to Inventor. All of this is going to work the same regardless of what version of Inventor you have. The look and feel and the tools available are the same whether you're running 2015 Inventor or 2018 Inventor. SDS for Inventor is not tied to releases of Inventor. It's only our own releases as we need and upgrades as we go along. There's a new upgrade coming out soon. It's just a small one, but it has some really nice tools that I'm excited about already. I've seen the preview for it, and I might have a webinar on that as well. But if we look at the Substation Design tools, we have import surface. We can import a XML surface so that we can see what levels and heights and variances in the ground that we can place in here and identify where we want our units. Again, this is Substation Modeling Strategy is designed to be able to change our heights. If this blue island here, the subassembly island, needs to be a different height because of the surface has changed from the import surface tool, we can easily move that group of items or individual items if we really wish and adjust for the hillside that the substation is modeled in. We have design checks. This is a favorite of a number of people, is they like the design checks. And what we do with design checks is we are looking at certain things here. We're looking at phase to ground clearance, phase-to-phase clearance, and fence safety clearance. So these are the design checks that we can check that we don't have a short or interference. So if we look at what I've already selected and set up, you can see I have different groups selected for different items. It's not quite complete because this is a demo, and I'd have to show a whole different model to be complete. But in this case, this is what we have set up just for this demo. A transformer has been added. You can see the transformer, and we've identified it as a 69 by 12. So that's what it's going to look like. We can show the equipment that we're using. There's the equipment identified, structures, and the insulators. So with that, we can come in here to design checks, and we can run phase-to-phase. So let's run the phase-to-phase design check. Again, this is being recorded, and it will be placed on the SDS YouTube website. The email or the web address for that is in the chat of the webinar tools. So you saw I ran the design checks, and let's look at what the design checks show. Design checks are a very nice tool. I've had really some good comments coming back from them regarding it. But if I look at what we're looking at in the design checks, I am on this line here. I need a required separation of 21 inches. The actual is 203 inches, so it's lots of room. And it tells me the two parts that it is checking it against. And you can see them, the highlight in here, those two items in blue. So it's checking that design check that it is not going to short across that it's beyond 21 inches. That 21 inches, of course, is configurable in the database tool. And that's the design check. So there's three types: phase to ground, phase to phase, and fence safety clearance. The UDH, another tool that we have, Utility Design Hub, that combines the 3D model with the 2D P&C line drawings and such, 3-line, 1-line drawings, and it has further design checks for your substation as well. So that's a third party that links the a third software from SBS that will link the 2D P&C with the 3D model. What we also have in here is a BOM tools. We can identify what our bills of material are going to look like. This is over and above the Inventor bill of material tool. We have bus design calcs. The bus design calcs were worked out with the SDS Consortium. The SDS Consortium is a group of users that I think we have about 478 members. I have it written down here. So 478 members for the SDS Consortium. And we've got together and we talked about what we needed for doing bus calculators or a Corona calculator. And that's available. The SDS Consortium, again, it's worthwhile to see, is a group we get together twice a year. It's free to join, and we can talk about what we want to see in substation design tools, software tools, whether it's P&C or the 3D or the Data Utility Hub tool that combines the two. So that is the calculation sheet. So that is a pretty quick overview of the software. If somebody wishes to ask a question, they can put it in the chat, and we can go from there. I'll look to see if I can add a different item in here. Okay, so I got some questions here from Matthew and James already, and I will keep running this until past 1 o'clock if it extends that long. Can the totalized bus lengths have any kind of bus cutting schedule auto-created based on length of bus procured? Bus cutting, I'm taking it you're talking about the ends being cut at different shapes. I would say not at the moment. But it is totalizing the length of the bus being used. So it's going to be totalizing the finish length. If you're thinking of the bus length is extended and cut to fit or something, it will only show the total length at the end of the at the finished design. Let's see if we can bring that up. So you come in here, we're going to look at our bus or cable. Here's my conduit. Here's all my 2 inches, 48 feet of this conduit. Flat bus, 33 feet of that flat bus. So that's how it's identifying. Here's some cable, the 500 cable stranded I put in. There's 29 feet of that. So it's identifying it like that. I'll go on to the next question from James. Are there any automated extraction tools for point cloud data? For instance, can you, in an automated fashion, model foundation steel cable We are working on that, and it's getting further. Those who use point cloud know it's still a little bit of an infant type of technology, and it's getting better. It's mostly dependent on the ability of different softwares to be able to analyze point cloud and get that information in there. Having said that, we can run SDS, we can run cable from a point cloud location to another point cloud location. We can combine the point cloud in Inventor with SDS software so we can lay it together in Inventor. And we have examples of that. I'm not prepared to show them today, but we are doing that. I have about 3 customers who are doing that a fair amount. My window's too small. Okay, Mason, how does the steel construction work? That is typically just straight out of what Inventor normally does for items. So I take it you're talking about steel structures. So the steel structures are typically done in Inventor. You can use frame generator from Inventor to create them, or you can create them by hand and assemble them there. So it's not part of the SDS software, but if you follow the substation modeling strategy, it will talk about best ways, best practice of putting this together and using it in the SDS 3D substation model. I noticed all the items are gray. Oh, this is Ryan. He wants to have color. Is there a reason for that? There is some value to actual colors, i.e. porcelain versus polymer, etc. Yes, you can add all the colors you wish. You can create that and put that in your database. The items with color, because I don't show it in here, is color will add to the amount the video card's got to generate. So on an enormous substation, you may have performance issues, but only on the biggest of substations. With the hardware and the software changing, it's getting a lot better all the time, so it's becoming less and less of an issue for color. The other thing with color, you have to manage it. If you assume that part is red and that's porcelain, if you say porcelain is all my red parts, you have to manage it and make sure that is true and not someone has made it red for some other reason. I much rather, my own personal preference is to leave everything as much gray as possible. If I need to identify what the part is, I can come into my item. I can just highlight that item, come in here, look at the eye properties. These eye properties should be telling me what that porcelain bushing is doing. If this porcelain bushing, my description should be telling me that and going in that direction. And this way I don't have anyone coloring something incorrectly and people assuming things, as well as you may run out of colors. If you're like me, a little bit colorblind, it's hard to see red from green. Does SDS incorporate point cloud scans? Inventor brings in point cloud scans. We've done it. We have several utilities doing that now. Daniel, could we see some designing inside the control house? So the control house in this case is just an empty shell. There's so much detail in a control house, it is arguable to leave it in a 2D AutoCAD world for the interior design. Or if you did want it in 3D, I would do it as a separate assembly and then just reference it from this assembly. So yes, you could design the interior of a control house totally in 3D, but there's so much detail there, I would simplify it for the larger model. There's a ton of information in these large models. The one I have here is pretty small, but when you get into a large station where it's several acres in size, that would be a lot of information to add, so it would be best to reference it outside of the main model. But in the end, yes, you could do designing in 3D of a control house. What was the tool for linking 2D and 3D? Is this different than the electromechanical link in the base AutoCAD software? Yes, it is. The UDH is the software. I don't have a quick link to it, but it's the Data Utility Hub. That is the one. Yes, the UDH, Utility Data Hub. Sorry, guys. Utility Data Hub is the tool, and that links the PNC with the 2D PNC with the 3D model. And that has further design checks, has some great bill of material tools in there. It's available on the SDS website. How does SDS play with structural designs? Not sure about that one. If a change is made to the sketch, will the ground grid design automatically update? Okay, all right. So those are two different questions from Richard. So Richard, it doesn't. The play with structural designs, it's totally independent on Inventor and how Autodesk Inventor you use to make your structural design. If you make your structural design out of frame generator, you change your sketch and the structural design will change automatically. Many people, they will template their models and store them in Vault or other data management like Adept or something, and they will place that stuff in there and use it as a library to pull the parts out. If a change, this is Richard's second question, if a change is made to the sketch, will the ground grid design automatically update? No, it will not automatically update, but it's quite easy to create a new ground grid. I can show that if we want to see that time. If I did make a change, let's open up the ground grid. I'm going to file and save this as another name. Let's call it ground grid 2. Ground grid 2 for Richard. We'll save that, and let's say I had this ground grid and I wanted to create another one. I'm going to come in here, I'm going to delete everything, and I'm going to run it again. Just to show you how easy it is to recreate a ground grid. So here's my ground grid geometry. I'm going to make that visible. Where's visibility? So I got my ground grid geometry here. Let's turn off the visibility of the dimensions. It doesn't want to let me do that. All right, so let's run our ground grid. Go on below grant. Let's generate ground grid. Here's my tool here. I am going to just take the defaults here, just because this is an example. I'm going to use the current assembly I'm in. I'm going to select the sketch, and I'm going to create the grid. And with that, you can see it starting to create the grid. It runs it pretty quick, and I can say done. And if I turn off the visibility of the sketch, we'll be able to see the ground grid we've added, and we've added a ground grid. So it's quite easy to add a ground grid. So I don't think it's a big deal if you change it just to run it again. Can we see a bigger substation? Well, I'm not going to open it at the moment. This is, let's look at this file here. So here's one of the bigger ones I've ran, and it's kind of hard to see. Let's zoom in here. This was a bigger one. You can see it has 4 bays on one side, on the high side, and 4 bays on the low side, with several acres as 2 transformers. It had 20,000 occurrences in there. I think it was on the plus side of 20,000. So you can see the amount of information that's in there. Had a very good bill of material, and we really did a good job on that one. I'm proud of that one. All right. Next question. Daniel, is the software available in international units of measure? Yes, it is available, and we can set it up that your default is in other units. Let's see, feet, meters, inches, and centimeters. So that's our default choices right there. If you want some other crazy astronomical unit, we could probably work that out too. But really, I think these are the main units that would be usable worldwide. Okay, Wayne. If adjustments to pier heights are required by bringing in the surface for top of rock, do the cable and bus runs need to be redone, or do they update on their own? Well, I like that question, Wayne. So let's look at our bay. Let's open up our bay again. If I wish to, let's say I'm going to bring this high voltage side up. Let's look at that, and let's just add, here's my constraint there. Let's bring it up 6 feet. All right, so that's 6 feet higher. You can see how that bay is higher now, and our cables don't work out here. I'm able to update the cable, and it should update and reroute back up to here. Because I did it quickly, I didn't look at my settings to make sure my settings were at the right size. So I can also edit my cable and say I want that cable to be not number 1, but back to the 500. Where's my 500 cable? Back to the 500 copper. And I can apply that. And with that, you can see how it updates to that height. So yes, if you change the height, so what a lot of people do, they will template maybe this whole assembly, have it fully populated, and they'll save it somewhere. And if they have a new job, they copy that template out, place it in their location, adjust the heights, and tweak it to whatever that location needs, and then they run it from there. So that's a typical workflow for that. Nice question, Wayne. Okay, Mike, how do I make sure the dual cable fittings, that the fittings I place in the middle of the cable run are orientated correctly? Sometimes the cables run in the opposite direction when they should be in a dual cable run. Well, that's a complicated question. And what we're looking at here is if I have a dual cable coming through here and coming through this fitting and coming to here, I believe that's what he's asking. And how do I make sure that this is set right so it flows through properly? And that's totally on the placement of your fitting, whether it's placed orientated left or right. So we don't have something that's going to go omnidirectional. You need to place the fitting in the correct orientation. Can you show an overview of how to create 2D drawings from a 3D model? All right, so we have our 3D model here. This is a question that actually David Santos brought this one in. David, that's a good question too, because I get that question fairly often. People are worried about what is my drawing going to look like. So I saved that file. I'm going to open up in the bay. Oh, in the bay, I'm going to open up a drawing that I've already made in here. Let's open up this drawing. Now it's going to update because we've changed the height over here to show you that earlier. So let's open that up and change it and take a look at that drawing. So you can see it's adjusted for that height. So to bring in a drawing view, you would just bring in the base view. I'm going to say which one I've got ahead of. I have it attached to the bay one. And if I want a profile view, I can have a profile view. I can move it to wherever I want. I have it set up to look at whatever scale I want. It tries to make a scale that's fitting for that size of paper. And I'm going to accept that. I'll put this in here, and I'll bring that guy in there. So there's our piece inside there. So now we have two drawings in here. If you zoom in on the drawings, you can see the detail that is available. It's accurate. It's far more accurate than AutoCAD when you're bringing in information, because it's exactly what it is. A lot of times over the years, AutoCAD blocks and drawings get changed. So there's your drawing. We can add dimensions. If I wanted to add a dimension, again, I have dimension type. I can put that dimension in there, and away we go. You can see we have several dimension types in there. If I want another view of this, I can take a view here, I can take a base view. Oh, sorry. I can take a projected view of this drawing and bring it here and create it. But I also can create section drawings. There's lots of tools in Inventor. That's just a typical Inventor question, that one is. Okay, John, will more models from vendors become available to use? Switches and control, yes, that is a definite yes. There's a number of vendors very excited. There's a number of vendors very excited about this, and they want to supply their pieces in there. And yes, we're getting more and more interest that way. In the fall, I believe we'll have a new cloud data that is quite exciting. It was displayed at the consortium in the spring. Again, that free consortium is worthwhile to join and find what's all going on in this world here. Daniel again, could we see example of this substation model in Autodesk 2D? I just showed a drawing of that, so I think that's covered already. Can Revit file structural be imported into Inventor? That's an Inventor question. It's not an SDS question, but the answer is yes. I have noticed Autodesk is communicating a lot better with their own software, so the interchangeability between Revit and Inventor has been getting better. When Revit first came out, it wasn't so hot. As far as communicating from one software to the other, it's a lot much better now. Curtis, my friend Curtis. Does the new version of the toolkit deal with orphans better? I'm assuming you're meaning files that are deleted or not used and removed from the model. If it's deleted from the file, I believe the answer is yes, but there's always improvement available or needed. Can you add cable spacers to cables that are connected to multiple single cable connectors? Can you add cable spacers to cables that are connected to multiple single cables? Okay, so that is in this area here. So let's look at this, and you can see I have two single cables with a connector in here. So the answer there is yes, we can do that. If I update those cables, what's my settings at? Dual cables. All right, I'm going to go with that. So let's make sure I got those right settings. I'm going to update those cables, and you're going to see them come up. Oh. So I don't like that. I thought that was set nicer than that. That cable, I don't know why she's telling it to 500 copper and apply. There we go. So you can see there's two single cables there with a spacer in there. All right, Nate, are the dimensions populated in the extraction or in the 3D model? The dimensions are in the 3D model. That's more of an inventor question, I believe. Do material marks get auto-populated? Material marks. I'm not sure what material marks are. Maybe ask that question again, but Curtis says yes, if that's the right answer. All right, let's see. Next question. I know this is from David. I know this is a function of Inventor, but there's no issues creating a 3D PDF from the model, correct? Correct. The only issue is in the older versions of Inventor 2017 and such. I don't have a 3D PDF. Oh, it just started in 2017. So 2018 of Inventor does the 3D PDF quite well. 2017 didn't do it as well. 2016 Inventor does not do it. So you need a third party software to convert your 3D model to 3D PDF if you're at 2016 or previous. But 2017, 2018 all have 3D PDF Direct. Works quite well. We've used it a few times. Okay. When you put a bus bar with aerial conductors, a catenary is calculated, or is it approximation? The catenary is strictly based on the percent sag, and it's from that. It's whatever percent sag you place in there. So if it is an approximation, it's an accurate approximation, if you want to say that. Nate, BOM numbers. BOM numbers, I don't know if you mean item numbers. I'm not sure what is being asked there, but if you look at the BOM here, let's save this so I can get a BOM going. Inventor BOM, and there's also the SDS BOM. But the SDS BOM is based on the inventor BOM, and then we add intelligence to it. But if I grab this BOM, come into here, you can see I have item numbers identified in here. I can sort this by whatever sort I need. This is typical inventor operation, and I have item numbers here. So if I had that item number, I can come into my bay and I should be able to grab my balloon. Say OK, and there's my balloon, and there's my item number for that structure. I can bring in a parts list into this model as well. It's all based on normal inventor practices. This software made the material list. The material list, I'm assuming you mean the BOM. The bill of material is whatever information we put in it will have the bill of material. So if I had a separate material type I could put in here, description, it's all from the information we place in there, all the metadata that we use. Okay, will anyone be teaching a class on SDS at Autodesk University? We will not be teaching a class at Autodesk University, but at the SDS Consortium in the fall, which would be held in San Diego this year. There will be lots of information, a lot of people talking about it. There'll be beginner groups as well as advanced groups in there. So I would look more at the SDS Consortium. There also will be classes your company can pay for, and again on online training as well. What version do you use? Is it a pro version? Okay, I think that's a inventor question. I would only want to use Inventor Professional. Again, the software is the same version. The SDS software is the same version for each release version. So I've come into downloads. So you can see we have for each release version of yearly version of Inventor, we have the same item, same SDS version for that software. So it will behave identically from version to version. We're not tied to the yearly release of Inventor. We have our own release. What is the estimate price if it is not appropriate to ask? I don't know what the price is right now. I'm not up to date on that. But in the handout, if you look at the handout, I've loaded the handout in the handouts folder. And here, this is the handout I've placed out. It just summarizes the toolbars. It gets a picture of the toolbars. At the bottom of this handout is Dwayne's email. And if you ask Dwayne that for the price, I think it's a reasonable price, but I'm a little biased. Okay, David, does the software perform some analysis, or is it geared more to modeling only? It's mostly modeling. There is some analysis with the design checks that we spoke about earlier. If you come into the design checks, the analysis is more on the ground clearance and face-to-face clearance, that type of idea there. So I think I've gone through some questions here. I don't know if anyone has further questions. You can email me as well. You've seen my email in the invite. You can email the support line is SDS support at, I'm putting this in the chat. So in the chat, I've put in the support line. You can email a question to that as well. Again, the video will be placed on the SBS YouTube website, and I placed that in the chat as well. You can read through the chat and you should be able to see that. So do we have further questions? I still have 37 attendees. Anything we want to review again, we can look at again, let me know. Okay. Well, I'm going to take it is that we can finish. We're going to leave it. I'm going to stop the recording and we're going to go from there. Thank you all for attending. I have further webinars, a little more advanced coming out. This again was just an introduction to SDS, and we can go from further detail in some other webinars that are being released, and you'll be notified if you wish. So thank you all again for attending.